Hello everyone, welcome to this session. In this session, we will learn about how to plot the graph for the different classifier. So here I will discuss about the plotting the decision tree classifier and logistic regression graph. So let's start here. So for that, for the drawing the graph, I've opened this Jupyter notebook. Okay, and we'll start the coding here. Okay, so first of all, I have loaded the CSV file. Okay, so what is contained in the CSV file, we'll see in the CSV file. So it contains the coordinate of the point in the x1 column and x2 column, and state positive or negative in the form of -1 and 1 in the column y. Okay. So this is data object contains the CSV file in the form of the data frame. So now I have created the numpy array. Okay, and I have passed the x1 and x2 column from the data frame. Okay, same way for the y also. And then what I have done, I have scattered the point in the graph, as I have already discussed in the previous session how to scatter the point in the graph. So this is the graph here. So where the blue point denotes the positive point and red point denotes the negative point. Okay, so now we will see. Now we are using the classifier. We will split the data into positive and the negative reason. Okay. So for that, what I have done, I have split the data into training set and the testing set. Okay, using the train test split. Now I have defined the classifier, decision tree classifier, and I have trained the model using the training set using the fit function. Okay. So now what I'm doing for drawing the graph, I have made a one function here where I have passed the classifier and x numpy array and y numpy array. Now I am finding the minimum and the maximum value from the column of 0 column of the x numpy array, and same way for the column 1 of the numpy array x minimum and the maximum value, and stored in the x min, x max, and y min, y max. Now this h is the resolution. Okay, you will come to know about it in later stage. So here I'm using the function arrange for knowing about the more detail about the arrange and the lean space and Meshgrid. Will go to the PPT here. Okay, so okay, so here let's study about the lean space first. So this function takes the argument as a starting point, ending point, and the number of elements between the starting and the ending point. So in this example, numpy array is created containing the three equally distributed points from -1 to 3. That is -1, 0, and 3, and stored in the X list. The second one, numpy array is created containing the four equally distributed points between the -1 and 2 or 3, that is -1, -3, -1, 1, and 3, and stored in the Y list. Okay, so now I'm using the Meshgrid function here. We will create using this Meshgrid function. We create a numpy matrix with the number of column equal to number of element in the X list, and number of row equal to number of element in the Y list. Okay, and the element of the X list in the X matrix will be placed row wise, and elements are repeated in the rows to form the matrix. And same way in the Y matrix, element of the Y list in the Y matrix, okay, will be placed column wise, and element will be repeated in the column to form the matrix. Okay, so this is the matrix you can see for the X matrix and the Y matrix here. Okay, and this correspond to the coordinate point. This -3, -3. Okay, 0, -3, 3, -3. Okay, now let's see what the function arrange to. Okay, sorry. Yeah. This is a lean space. This is arrange. Okay. So let's see the arrange function here. It take this parameter as starting point, ending point, and resolution. So for example, x value. contains the point from -3 to 4 with a resolution of 1. That is, so it will contain the -3, -2, -1, 0, 1, 2, 3. Here in this function, ending point is not included. Same way for the y value also. Okay. Now using the Meshgrid function, matrix x and y is created. Okay. So this x is created and y matrix is created of the same size. X and y will be of the same size, and so that the coordinate will be this. The corresponding element of x and y will take as the coordinate of the point. Okay. Now we will see. Now you can see here. You can plot the point in the graph here, where the x matrix contains the x coordinate and y matrix contains the y coordinate, and corresponding value are used to plot the graph here. Okay. So this coordinate x, y. Okay, we are giving it and plotted the graph here. Okay. So okay. So now let's see. Now we will go to the another slide and we'll see the two function of the NumPy array. Okay, that is Ravel, okay, and the C underscore. Okay, so Ravel helps to combine the two array and result into the single array. Okay, so if you do this, it takes the parameter 2 array and it will convert into the single array. It will represent as a single array. Okay, and a C underscore take the two argument, 2 NumPy array, and it result into the 2-dimensional array. C underscore takes a 2 argument, 2 NumPy array, and it results into the 2-dimensional array. Corresponding element of the first array and the second element array is combined together. Okay, so now going to the another presentation. This is how to plot the counter plot. So x val and y val, okay, which we have discussed before, and now we have seen the Meshgrid that creates the two matrix x and y. Okay. So this creates the x and y matrix. Okay. So now what I am doing here, I am creating each element of the y is multiplied with the corresponding element of the y and stored in the Z matrix. So this is the Z matrix here. Okay. So now using the Ravel function, I've converted this matrix into the single dimensional array and stored in the K. Okay. So this was the Z, and I have converted into the single dimensional array. Okay. Now I'm checking each element of the key whether it is positive or negative value. If it is positive value, then I will append a +1 in the R list. Otherwise, I will append -1 in the R list. Okay. So using this loop, I will do this. And now what I'm doing, then I'm converting this list into the NumPy array. This list, which I have converted as NumPy array, and we have resaved into the X matrix. First it was single dimension, now it will convert into the X matrix of its size. Okay. Now our matrix will look like this. Okay. Now in order to plot the graph, I have mentioned X limit and Y limit here. Okay. Okay, the -3 to 3 and -3 to 3 for the Y limit. Yeah. Now using the function counter f and passing the argument x and y and R matrix and also the color. So this function checks the coordinate which is stored in the x and y matrix and checking the corresponding value of R, whether it is +1 or -1, color is decided. If R value is -1, then the color is red. So color I have already mentioned here, R and G, that is R means red color and G means green color. So this one will take the lowest value. So here only in this it has -1 and 1. So this -1 will correspond to this red value and 1 will correspond to the green value. Yeah. Okay. So the graph will look like this. Okay. So for the negative points, all will be filled with the red points, and for all the green point will fill with the positive point. Okay. So this was how what do we mean by this Meshgrid, arrange, and the lean function. Now coming to the this coding function. So here the coming back here to Jupyter Notebook here. So we can see here this arrange function is used here to, and we have passed the argument xmean of the xmean and xmax value and resolution of 0.009, and this x value stores all the value from the xmean to xmax with a resolution of 0.009. Now same way for the y value also. So now we will use this Meshgrid function is used to create the matrix x's and matrix yy. So here now we will use the c underscore function here to combine the element of the x's with the corresponding element of the yy. And then we will predict the function. We will use the predict function to predict whether the point is positive or negative, and it is stored in the z. Now we will reshape reshape z in the x like a x's matrix. Okay. Now the c stores a color value, and it is passed in the argument of the contour f. And if the z value will be negative -1, then color will be magenta, otherwise it will be green. Okay. In this way, each point between the x mean to x max and y mean to y max, it is predicted and the graph is plotted. And resolution taken here is small, so that every section of the graph is predicted and plotted the graph. Now we will plot the point which is there in the CSV file and scattered in the graph. So this is how the graph will look. Now we can see here that this blue triangular point is misclassified in the red region. This pink one is the red region, and this green is the blue region. So these points are misclassified here, and red is misclassified in the blue region. Okay, so this is how the graph will look here. And by just looking this graph, you can identify which classifier is best suited for the data. Same way you can do for the logistic regression. Same function will be used. Only you have to define the classifier and train this model. Okay. So for that, the same graph will be plotted here. So red region will so that this is the blue region, and this is the green. This is a red region. So here you can see the red region. These are misclassified here. Okay, and in the blue region, this red points are misclassified. So in this session, you have learned about how you can plot the graph for the decision tree and logistic regression. So that's all for this video. I'll see you in the next video.